If you're a data engineer, an analytics engineer, or someone breaking into data and you keep hearing about Databricks but don't know where to start, you're at the right place. In this video, I'll walk you through the entire Databricks platform from scratch, the data lake house architecture, Delta Lake, the Medallion pattern, Unity catalog, PySpark, and I'll show you live demos of setting up your workspace and writing your first notebook completely free. I'm building an entire Databricks 101 series on this channel, and this video is video number 1. So if you don't want to miss the rest, subscribe now. Let's get into it. So what basically is Databricks? Before I answer this, let me show you the problem it actually solves. Imagine you're a data engineer at a company. You need to ingest data from different sources, store it somewhere cheap, transform it, run analytics on it, and maybe even train a machine learning model. Without Databricks, you're stretching together 5, 6, 7 different platforms. You've got S3 for storage, maybe EMR for Spark, a separate data warehouse for analytics, some governance tool bolted on top, and a bunch of glue code holding it all together. It's fragile, it's expensive, and every time something breaks, you're debugging across 3 different systems. Databricks replaces the entire fragmented stack with one unified platform. And here's the key insight. The people who build Databricks are the same people who created Apache Spark. 7 researchers from UC Berkeley founded the company in 2013 after building Spark at the AMP lab. They saw companies struggling to run Spark at scale, so they built a managed platform around it. Think of it this way. Spark is the engine, Databricks is the entire car, with GPS, climate control, and self-driving features. You could build the car yourself around the engine, but Databricks saves you years of work. Now, the architecture that makes all of this possible is the Lakehouse. For decades, companies ran 2 systems, a cheap data lake for raw storage and an expensive data warehouse for analytics. The lake was flexible but messy, no transactions, no reliability. The warehouse was reliable but expensive and couldn't handle unstructured or machine learning workloads. The Lakehouse combines both. You get the cheap, flexible storage of a data lake plus the reliability and performance of a data warehouse, all in one system. One copy of your data serves all workloads, ETL, analytics, machine learning, everything. And the technology that makes all of this possible is called Delta Lake. We'll get into it in a few minutes, but first, let me show you how to get started for free. Because yes, you can run all of this without spending $1. Here's the best part for getting started. Databricks launched a completely free edition in June 2025. No credit card required, no AWS or Azure card required, no cluster configuration. You go to the sign up page, authenticate with Google or Microsoft, and Databricks provisions a full workspace for you in 60 seconds. This isn't some stripped down demo. You get serverless compute, Unity catalog, an AI assistant, sample datasets, dashboards, and even some pipeline tools. It replaced the old community edition, which was a tiny 15 GB microcluster. The free edition runs on the same serverless infrastructure as paying customers. Once you're in, here's what you'll see. The workspace has a unified sidebar on the left. Databricks got rid of the old confusing personas feature that they had, in which you had to choose between data science, ML, or SQL views. Now everything lives in one single sidebar. The 6 items you need to know: workspace, that's your file explorer for notebooks. Catalog is where you browse and manage tables and data. Compute is where you manage your compute resources. Jobs and pipelines is where you schedule automated workflows. And right at the top, there's a plus new button. That's the fastest way to create a new notebook, a query, or a table. And there's the global search bar that searches across everything. Now compute, there are 3 types of compute that you should know. All-purpose compute is for interactive work. You configure it manually. It takes about 5 to 12 minutes to start, and it's the most expensive because it charges you while you are idle. Job compute is for automated workflows. It is cheaper, auto terminates when the job finishes, and there is serverless compute, which is zero configuration, starts in seconds, auto scales, and you only pay when the code is actually running. For beginners on the free edition, serverless is the only option, and honestly, it's the best option anyways. Databricks recommends serverless as a default for all supported workloads. Quick note on the costs. On the free edition, the costs are zero, you pay nothing, but if you move to a paid tier later, the number one beginner mistake is leaving an all-purpose compute cluster running idle. The default auto termination time is 2 hours, so you'll be burning 2 hours of money doing nothing. So I would highly recommend setting it to 15 or 30 minutes. Better yet, you can just use serverless where there's no ideal cost. I'll cover cost tracking and optimization probably in a dedicated video later. Subscribe so you don't miss that one. Alright, now let me show you what it actually looks like to write code in Databricks. Let me walk you through creating your first notebook. Click on the plus new button in the sidebar, select notebook. A blank notebook appears instantly. Rename this by clicking on the title at the top. And here's the cool part, compute attaches automatically. On the free edition, it defaults to serverless, so you don't have to configure anything. Just start typing code. Now let's run 3 cells. Cell number 1 is just a simple hello world. Hit shift enter to run. Serverless compute spins up in about 10 to 30 seconds on the first run, and then it's an instant after that. Cell number 2 creates a data frame with numbers 0 through 9 and renders it as an interactive table. You can sort it, filter it, and even create charts from it. Cell number 3 pulls a real NYC taxi trip dataset that comes preloaded in every workspace. Now you probably noticed I use this Spark variable without even defining it. Every Databricks notebook comes with a pre-initialized object called Spark. This is your Spark session, your single entry point into all Spark functionality. You read it to read data, run SQL queries, and create data frames. Never create your own Spark session. The documents explicitly warn against it. Also, you can use the display instead of show. Display is Databricks' native command, and it gives you an interactive table, charts, and profiling, whereas show just prints plain text. And the print df just shows the schema, not the data. So now you've got data loaded into a notebook, but what makes the storage layer special? This is the next part. We're going to talk about Delta Lake. This is honestly the most important concept in the entire video, so pay attention. Delta Lake is the storage layer that makes the entire Lakehouse work. It's a layer that sits on top of your cloud storage, whether it is S3, Azure, or Google Cloud. Under the hood, your data is stored as standard Parquet files, but Delta adds a transaction log. There's a hidden folder called Delta log that tracks every single change made to these tables, every insert, update, and every delete. This log is what gives Delta its superpowers. The first superpower is ACID transactions. Without ACID, if a write job crashes halfway through, you get orphaned files corrupting your table. With Delta, it writes either fully succeeded or a fully failed trail, nothing in between. That's atomicity. Consistency means schema enforcement. You can't accidentally insert a record with the wrong column types. Isolation means the reader always sees a clean snapshot even while writes are happening. And durability means commented data survives any system failure. On Databricks, every table is a Delta table by default. You don't configure anything, it just works. The second superpower is time travel. Every write creates a new version, so you can query any previous version. Watch this. Once I run this query, it pulls a version 3 of the table. You can also pull versions as of the timestamp date. You can even roll back to particular versions using the restore table command. So let's say you have a bad deployment that corrupted your data, one command and you're back. And the default retention is 7 days for data files. How do you organize data in Delta tables? This is where the Medallion architecture comes in. And once you understand this, you'll understand how every serious data team structures their lakehouse. The Medallion architecture is the bronze, silver, and gold layers. Think of it as a quality pipeline. Bronze is the raw layer you ingest exactly as received, no cleaning, no transformation. A CSV lands from a vendor, you dump it straight into the bronze delta table. Silver is where you have validated data. So data that you have cleaned, deduplicated, cast types, handled nulls, and joined with other sources. Gold is the business ready data which is aggregated for dashboards and reports. For example, revenue by region, daily active users, sales pipeline summaries, etc. So why three layers? If a business rule changes, you only reprocess the silver to gold without re-ingesting from the source. If the source data is corrupt, the bronze still holds the truth. So you've got reliable storage organized in layers, but how do you control who can access what? That's where Unity Catalog comes in. And honestly, this is a part which a lot of tutorials skip for some reason, but I think is very critical if you actually want to work on a real team. Unity Catalog is Databricks' governance layer, and it organizes everything through a simple three-level namespace: catalog.schema.table. Think of it like a file cabinet. A catalog is the top level drawer. Maybe you can call it prod or dev. A schema is a folder inside that drawer, something like sales or marketing. And the tables are the files inside. So when you query data, it looks like this. Select all from main.default.mytable. The old Hive metastore only had two levels: database.table, which meant no environment separation, but the Unity catalog adds that catalog layer on top. As of December 25, all new Databricks accounts use the Unity catalog exclusively. It's not optional anymore. One more thing worth noting: Unity catalog doesn't just govern tables, it also governs files through something called volumes. Volumes are for non-tabular data, CSVs that you just ingest, images, jar files, config files, anything that isn't a table. A path looks like this, where it has the volume, catalog, schema, volume name, and your file. Think of it this way: tables are structured queryable data, and volumes are for files. Volumes replace DBFS, which is deprecated as of the end of 2025. So if you see old tutorials using DBFS paths, that's the old way. To browse all this, you can click on the catalog icon in the sidebar. This opens the Catalog Explorer, a visual interface where you can click through catalog, schemas, tables, and volumes without writing any SQL. Once you click on a table, you can get the tabs for overview, sample data, history, and lineage. Lineage automatically tracks what tables feed into each other down to the column level, and there is no setup required. Security is deny by default. Nobody can access anything until you explicitly grant it to them. There are three grants which cover most scenarios. Use catalog lets someone navigate to the catalog, use schema to the schema, and select to read a given table. I'll go much deeper into security and governance in a dedicated 101 video that is coming soon. Now that you know how data is stored and how it is governed, let's talk about how you actually process it. This is the hands-on part, the stuff that you'll do every day as a data engineer. In the Lakehouse, the data processing follows the ELT pattern, which is extract, load, transform, not ETL. The difference: you load raw data first, then transform it inside the platform. Why? Because storage in the Delta Lake is cheap. So you can load everything immediately and preserve the raw data for reprocessing, and use Spark's distributed compute power to transform it. There is no external staging area needed, and ELT maps directly to the Medallion architecture. Extract plus load equals bronze, that is the raw data lands as is. Transform equals silver and gold, where you clean, validate, and aggregate. And you need only about 8 or so operations to handle most data engineering work. Filter to keep the rows that match a condition, select to choose particular columns, group by and aggregate for aggregations, order by to sort, join to combine data frames, and write.saveTable to save results. The idiomatic way to write PySpark is method chaining. So you can also pipe operations together one after another. So you can read a table, filter for the completed sales, add a tax column, group by region, aggregate the totals, sort by revenue, and save as a gold table all in one fluent chain. And here's what a lot of people don't realize. PySpark and SQL produce exactly the same execution plan. Both go through Spark's Catalyst Optimizer. So that entire PySpark chain I described, you can write it as a single create table as select statement in SQL with a where clause, group by, and order by. You will get identical performance and it's completely up to your preference. The general recommendation is PySpark for complex transformation logic from bronze to silver and SQL for analytical queries for silver to gold. I'll cover real ETL patterns with full code examples in a video coming soon. One concept worth noting is lazy evaluation. When you chain PySpark operations, nothing actually runs until you trigger an action like show, display, or write. Spark builds the entire execution plan, optimizes it, and then runs everything at once. It's like a GPS calculating the best route before you start driving instead of turning at every intersection. And for production pipelines at scale, Databricks has Lakeflow, a unified data engineering product that handles ingestion, transformation, and scheduling. That's an advanced topic that we'll cover in an upcoming video. Here are 4 advanced features that you should know exist. First, autoloader. Instead of creating code to check for new files in cloud storage, autoloader watches a folder and automatically loads new files into Delta tables as they arrive. It handles schema changes, guarantees exactly once processing, and it never skips or double counts a file. Second is predictive optimization. Databricks can automatically compact, reorganize, and maintain your tables so queries run faster. Earlier, you had to run optimize commands and handle partitioning strategies, but now the platform handles it for you. Third, monitoring. Every query you run is logged in the query history with execution plans and timing. There is built-in data quality profiling that tracks drift over time. System billing tables let you track every dollar of compute spent. And fourth, security. We already covered Unity Catalog's deny by default model, but it goes deeper. Row-level filters that help you show different data to different users, column masks that redact sensitive fields, and automatic audit logging of every access. The key message across all 4 is that Databricks automates the hard parts of data engineering so that we can focus on actually building pipelines, not maintaining infrastructure. Each of these gets its own 101 video in the series, so subscribe if you haven't already so that you can catch each and every one. So a quick recap, 5 key takeaways. 1. Databricks is a unified Lakehouse platform built by the creators of Spark. 2. Free edition gives you production grade access at zero cost. 3. Delta Lake gives every table, asset transactions, time travel, and schema enforcement. 4. Unity Catalog organizes everything in a catalog schema table namespace with deny by default security. And 5. PySpark and SQL are interchangeable. They have the same optimizer and the same performance. Now, if you're serious about breaking into data engineering and want the full roadmap, not just Databricks, But SQL, Python, cloud, pipelines, interviews, everything, I made a complete 4-month learning plan video. I'll link it right here on the screen and in the description. Go watch that next. And if you found this video useful, hit the like button. It genuinely helps the algorithm show this to more data engineers. Subscribe if you want the one-on-one deep dives when they drop, and leave a comment. What Databricks topic should I cover next? Do you want me to cover ETL patterns, cost tracking, optimization? Let me know. Thanks for watching, and I'll see you in the next one.